All right, there we go. So question one is asking, of the following transitions in the Bohr hydrogen atom, which transition results in the emission of the lowest energy photon? So emission, we're releasing energy. So we're going to be on the way down. So we can immediately cancel a few of these. We can cancel, yeah, I'll answer that in some other questions. Right, so emission, we're releasing energy. We're going from a higher energy down to a lower energy. So I can immediately cancel out choice A, choice D, because those, oh, no, I can't cancel out choice D. Yeah, I can. Emission, right? We need to be going from a high to a lower energy. So I can cancel out D. And I can cancel out E because these, right, A, D, and E are all absorbing energy. They're going up from the first quantum level to the sixth quantum level, right? To go upstairs, we're going up in higher energy. It's the same thing here. So we're looking for something that's going down in energy. So 6 to 1 is going down more steps in energy than 6 to 3. So 6 to 3 is a smaller energy gap. Because it's a smaller energy gap, it's going to have a smaller energy of a photon that it's releasing on the way back down. But A, D, and E, right, that's all absorption. So we can cancel out those. B and C are the only two that are releasing a photon, and B would be higher energy because B is a larger transition. Yeah, Anthony, do you have a question?
Yeah, I have a question. So when we go, how do you know what's absorption and what's emission?
How do I know what?
How do you know what is absorption versus emission?
Yeah, it's like I was saying, anytime we're going up, right, we're going from the first level to the sixth level. Level six, like think of the sixth floor is higher, right? The sixth level is higher in energy. So anytime we're headed, if you remember our energy diagram, all right, here was energy 1, 2, 3, 4, 5, and 6. And so energy level 1 is our lowest energy level. So for me to go to energy level 1 to energy level 6, I had to absorb a lot of energy. Well, on the way back down, right, if I'm this electron that went from 1 to 6, well, on the way back down, right, that electron has to release that energy. So going upstairs, we're going up higher in energy. On the way down, we're going to release energy, and electrons are going to release that in the form of a photon of light. They're giving off a photon of light of equal energy to that transition.
Also, one more question. This question might be a bit silly, but I was wondering if will we always be given a starting energy level, or will there ever be a question of test where we have to find out energy level for ourselves?
I mean, we did cover an equation where you could calculate the energy of a specific energy level, but more often we calculate the energy transition, the energy change between two quantum levels. But yeah, it's possible that you could find, it's doable to find the energy of a given level, and it's also possible to find the change in energy between those two levels. Yeah, so question 2 is going to be our standard. I gave you frequency, we're asked for energy, so we should think there are only, right, 2 equations that calculate energy. There's only one equation that relates energy and frequency directly, right? And that is energy equals Planck's constant times my frequency. So the energy of that photon equals Planck's constant 6.626 times 10 to the minus 34 joules times seconds. And my frequency in this case, 5.64 times 10 to the 14. inverse seconds, multiply those two together, we're going to get something to the minus 19 joules. It's 6.626 times 10 to the minus 34 times 5.64 times 10 to the 14th. And right, three significant figures, because I've got three significant figures there. So I would say 3.74 times 10 to the minus 19 joules, because seconds cancel out. When we multiply, we're left with joules. Energy should be in joules. Yeah, question 4 is going to be very similar, right? The Navy communicates with submerged submarines at a very low frequency. The frequency is 2.14 10 to the 4 hertz, right? To penetrate the ocean water to a depth of 30 to 40 meters. What is the wavelength, right? So there's one equation that relates wavelength and frequency, and that is the speed of light equals my frequency times my wavelength. We're looking for wavelength, so I'm going to divide both sides by my frequency. So frequency cancels out. Wavelength equals speed of light divided by my frequency. So the wavelength of this, right, speed of light, 3 times 10 to the 8 meters per second, over my frequency, 2.14 times 10 to the 4 inverse seconds. I'm going to divide, seconds cancel out, and that's good because wavelength should be in meters. So 3 times 10 to the 8 divided by 2.14 times 10 to the 4. And we get something like 14,018 meters, so like 14 kilometers. So pretty close to like between 8.5, 8.8 miles, something like that. And then let's see, for significant figures, right? 3 sig figs again. So 3 sig figs would be 1.40 times 10 to the 1, 2, 3, and 4 meters would be our wavelength for question 4. Yeah, Anthony, what do we have?
What equation was that?
We started off with the speed of light equals my frequency times my wavelength, because that's the only equation we know that directly lets us go from frequency to wavelength. Because all of this electromagnetic radiation from TV waves, radio waves, IR, visible, UV, X-ray, gamma rays, all of that's moving the speed of light. And yeah, Sophia, I'll always give you, like on the practice exam, you'll have the speed of light and you'll have Planck's constant given to you on the exam. We'll jump to question.
Yeah, I have one more question. Like the stuff like for example, like the value of speed of light and Planck's constant, those kind of things will always be given to us, like constant values.
Yeah, that's what I just said to Sophia. Yeah, I'll give you the speed of light. I'll give you Planck's constant, just like on the practice exam. Yeah, Paulo, that's an interesting question, right? Do all the waves move the same through water or air, right? And there is a change as they move through, as they hit, right? We've all observed that when water hits, or sorry, when light hits water, there is a change, right, when they hit that water, because it's a different medium than the air that they're traveling through. So yeah, that is a good question. It does change the behavior of those waves. Question 9, let's see. Oh, okay. What does the n or principal quantum number tell us about the electrons in an atom? Choose all the answers that are correct, and it's not on the same page, unfortunately. So the principal quantum number, n, it tells us what energy level we're starting with, like 1n, n equals 1, so 1s or 2s or 3s, that's telling us, right, the electron's energy. It's not telling us the shape because that's the S, P, D, or F that tells us the shape. It's not telling us the specific subgroup, right? It is telling us how far we are from the nucleus because one is the first quantum level is closer, the second quantum level, the third quantum level, the fourth quantum level, we're getting larger and larger and larger. So A and D, and then it doesn't tell us about the direction of magnetic field, right? That's the spin, right, of the electron. So yeah, for question 9, our quantum number n just tells us basically the energy level and the size of that orbital that we're working with.